How's it going, y'all? So, for the past couple months, I have been working on this 3D navigation and pathfinding system for a game that I'm working on that features flying AI agents, like what you're seeing here. The purpose for this package is to address an issue that is not really addressed by the built-in Unity navigation AI package, which is a 3D navigation. So, the normal AI navigation package uses surface-based navigation. It's 2D. The only 3D thing that you can really do with it is being able to climb and step over things, but that's not really sufficient for a truly 3D navigable agent like what you're seeing in front of you, this drone. And as you can see, it's currently navigating around in 3D. So it's pathfinding in 3D. It uses voxel-based navigation as opposed to like I think planar-based, like grid-based navigation. So it's a little bit more robust for that reason. And I wanted to kind of like show you how to set it up and what it comes with, stuff like that. So what Nav3D is a system, an API, if you will, for creating your own agents. What I provide is the pathfinding functionality, some debug and testing tools and utilities, and yeah, that's I mean that oversimplifies it, but that is what it is for the most part. So what it does require you to have some level of like not necessarily expertise in C# scripting, but at least the willingness to write C#. What Nav3D is not is a complete end-to-end solution with drag and drop agents that you can just like throw into your game and start and ship and make a full game out of. You might be able to get away with that with one of the samples that I provide, which is the one that you're seeing in front of you, the combat drone agent. But these are just provided as samples. They're not meant to like be templates or like end-to-end complete agents, not even a little bit. So I want to make sure I like set the expectations appropriately first, because I don't want to mislead anybody who might be looking to purchase this asset and then being disappointed when they end up just seeing that it's like mainly a bunch of code. So now that we got that out of the way, let's go ahead and start going through what it looks like to set up a scene with 3D navigation. So I'm going to stop this gameplay real quick, and I'm going to head into my assets folder. I'm going to open scenes, and I'm going to create a new scene. I'm going to start this from scratch so that you have an idea of what it would look like end to end. So we're going to create a new scene. We're going to just call this demo, and I am going to be doing two scenes. I'm going to be doing a demo. We'll just call this simple, and then I'm going to be doing another demo later on. It's going to mostly be the same with maybe some more advanced concepts in it, but that one's going to be using the Cinti sci-fi city asset, and this is just to show you how you would use this with a third-party asset so that you can see like what the process looks like across both examples. So the simple one, this is only going to be using the stuff that's built in, including the drone that's built in that I provide with the asset, so that if you don't have the Cinti asset or you're not interested in that, you can at least follow along with this and get a good idea of what everything is and what you can do with it. So first things first, we're going to create a plane to represent the ground. I'm just going to reset the transform over here. We'll give it a y and x of 10, or sorry, an x and z of 10, so that it's a little bit on the bigger side. And then I'm going to come in here and just add a few things. So we'll add a cube. We'll give this a height of, I don't know, we'll say 100, or that's an x. We'll give this an x of, we'll say 9, a y of 5, and a z of 10, right? These are just going to be like thick cubic-like obstacles to place around here, just so that we can see what it looks like when you're baking the navigation volume. Maybe we'll add another one. We'll make a few towers. So for these, we'll change the y to something like 50, and we'll make the x something like 4, and the z will make it like 6, like that. And we'll just place a few more of these around. And then for the sake of being thorough and given a good amount of examples, we'll just add a couple more 3D objects. We'll add a few spheres. We'll make these 8, like so, and we'll just, duplicate these around just so that we have some variety. Cool. So there we go. We have a nice little scene with some obstacles in the way. And what we'll do is create a game object to place these under, just so that it's easier for us to navigate. So we'll just call this environment, and I'll place everything within that, like so. And now we can come into the add game object or create game object button, come down to M6IO, and in here, you'll see Nav3D, create navigation volume. So you can think of this as your navigation mesh equivalent from the Unity Navigation AI package. And what this represents is the area that whatever agents are going to be using this specific nav volume, this is going to be the total area that they're going to be able to access. Yeah, so this can be as big as a whole scene, or preferably the size of whatever you want that specific agent's like nav region to look like. You can have multiple of these, right? So if you have multiple of the same kind of agent that are navigating in different parts of the map, and you only want them to like sit within their specific areas. So like for example, if I come over here and I have a second volume, I'm just going to always show the gizmo so that you can see how both of these look while they're both in the scene. So if you have something like this, let's say this one is like, I don't know, 40 by 40. So whatever agents you define that use this volume, they will only be able to use this volume. And whatever agents you define that are using this volume, use this volume. So we're not going to be doing 2 volumes in this example. It's just going to be 1, but this is just to kind of illustrate the point. So I'm going to undo this a bunch of times just so we can get that dupe out of the way. We'll turn always draw gizmos on. This is not a good idea to always have on when you're playing the game. This is just for debug purposes. If you're playing, this can cause a lot of hitching because it is always rendering gizmos, and you'll see what I'm talking about in a second. So just for the purpose of like performance, keep this off unless you need it for debug reasons. So let's come here and we'll change our voxel size to 1, and the voxel size represents this volume is going to be broken up into a bunch of cubes. This represents the size of each one of those cubes. The smaller this is, the more cubes they are, which means the smaller the cubes are, the more accurate your pathfinding is going to be, but it's going to be more data and it's going to come at the cost of performance. So change this according to your needs. In this case, we have a humongous volume, so I want the voxel size to be limited to something reasonable. We'll make the height something like 50, and we'll go ahead and bake this just so I can show you the error handling. So it is going to, I guess it didn't fail. I expected it to fail. Oh, okay. Yeah, it didn't fail because it would fail if I come here and I do something like 0.5 maybe. But let's make the obstacles anything that has the default layer. So these are all on the default layer, and we'll try that again. Yeah, so it's going to fail this time because the amount of cubes that it will make far exceed the maximum that we defined. And this is like a way to just kind of cap yourself for performance reasons. You can increase this if you insist on having a lot of voxels, or you can change your voxel size if you want to maintain a performant scene and make sure that you're not going overboard with your voxel count. So it's just a way to like safeguard your implementation from turning into an unperformant mess. So again, we'll go ahead and bake this. So you can see it takes a lot longer to bake too because there's a lot more voxels and cubes that it needs to account for. There we go. And there's several options for visualization. The most optimal option is showing an octree, and that's because it groups all of the cubes that represents multiple voxels. It groups them together as best as it can to reduce the amount of gizmos that are showing up on scene. So in this case, we're showing like how many? So we have 4 million voxels, but only 38,000 octree nodes. So it's a much, much lower amount of debug visualizers, if that makes sense. So it's a little bit more performant to do it this way. I would recommend using this unless you absolutely need to have exact visualizations, because the tree does take like shortcuts to simplify the visualization as much as it can. But if you need it to be exact, like you need to see exactly what the baked data looks like, that's when you would use the unnavigable voxel gizmo, enable that to see what those look like. So now that you kind of have an idea of what the nav volume looks like when you bake it, let's go ahead and add an agent in here. So we're going to come in here and I do have some prefabs. This gives me an opportunity to show you the stuff that comes into the package. So we'll just look up copter, and these are the same ones that I provide in my drone controller asset. So if you have that asset already, you'll be familiar with these. But in this case, we're going to add a quadcopter. It's exactly what it sounds like. So again, these come built into the asset. So these are for your benefit to enjoy. And first things first, I do want to change the layer from default because we're going to be using default as a representation of the obstacles in this case. So we'll just change this to drone. If you have your own asset, I would recommend doing the same. Now we can go ahead and add our combat drone agent. But before we do that, I do want to add a sphere collider, and the sphere collider should be sized based on your based on the size of the drone that you're going to be using when you define your nav connectivity. So in this case, our radius for the collider, we'll just give it like a 0.25 radius. I think that should be sufficient because that way the muzzle of the turret is outside of the collider. And speaking of the muzzle, we can go ahead and create a game object. We'll call it muzzle. Most of my game objects that I provide to you, like if they have the dash base, they should already have a muzzle defined. This is just the model, the FBX model. So I'm just gonna unpack this completely. That way we don't override any prefabs by accident. And the muzzle will be reset this and then shift it down somewhere in front of the turret. It doesn't need to be right in front of it. Just this is basically where the projectile is going to spawn from. And now we can add the combat drone. Combat drone takes in a few things. It's not going to take in a navigation volume, because the navigation volume is, it defines the within the bounds, it defines all like this huge grid of all of these cubes that represent yes or no. Basically, is this blocked or is this unblocked? These cubes are all sized at 0.5, right? But that doesn't mean that the agent is going to be 0.5. The agent might be smaller or bigger. So where the agent fits, that needs to be solved in advance using something called a connectivity graph, which we will go ahead and add right now. And I don't know why my mouse just failed on me. Let's try that again. So nav3D, create agent connectivity. And the way you would use this is for each volume, like a volume represents the area that can be navigated, right? The connectivity represents the agent specific navigation data. So this is all per agent radius. If you have like 16 agents that are all the same size, which is 0.5, then they can all share that connectivity because that is subjective to that size. But if you have another agent that's like 1 or 0.25, then you would use a connectivity for that. Which reminds me, in our case, our agent is 0.25 and our volume is this one right here. Because remember, you can have multiple volumes per scene, right? So you want to make sure you're being specific to which one. So now we have our connectivity and we can go to our quadcopter and we can add our connectivity like so. I'm not going to deal with the target right now because we don't have one, but let's add some patrol points. So we'll come in here, we'll add a few empty game objects. We'll just call these patrol points like that. Patrol point. Okay, and duplicate these down a few times. And I'm going to select all these and I'm going to add a debugger here. There's a script called navigation waypoint that shows you, well, it shows here, I'll show you what it shows you. So we'll add a navigation volume to these and we'll set the agent radius to 0.25 because that's what we're currently debugging. In the future, I'll probably change this to accept the connectivity, but for now, this should be fine. And we can start moving these around. Now, I'll kind of show you what this does. So when you're navigating, you want to make sure that you're not accidentally going somewhere where you're not supposed to go. Like I just moved this patrol point all the way down here. Because that's outside the volume, it'll snap it to the closest navigable place inside of the volume. If I come inside of here into this blocked tower region, right, like that, well, it's not in there yet. Let's move this around like that. It's kind of hard to do in 3D. There we go. And we'll just shift it up. So you'll see that we're inside of an unnavigable area. It'll snap it to the closest navigable spot within the volume. All right, a little bit of a useful aid. And that's exactly how the Pathfinder works. It doesn't navigate to the point that it doesn't always navigate to the point you define. It navigates to the closest navigable spot to the place that you define. If the place that you define is navigable, then it'll navigate there. Otherwise, it will navigate to the clamped navigation point. So now let's go ahead and align these in a way that makes sense. So we'll just put the first patrol point somewhere over here. Say it's a little higher. Second one is down there. Third one, we'll put this, I don't know, somewhere over here. We'll shift it behind this little cube so we can see how it rounds about things. And then the last one, we'll put this one somewhere like, oh, put this one outside so that way you can see how it looks when it tries to go somewhere it can't go, like that. Okay, so now we can go ahead and click on our quadcopter again. I'm going to lock this so that I can click multiple things outside. I'm going to select these four, drag and drop them into the patrol points. And the combat agent I provided also has rotor animations if your agent is a rotor. If your agent is like a copter-like agent that needs rotors. So we can go ahead and add those like this. So I'm just going to select the propellers and I'm going to drop them into this rotors. So now it'll animate those when it flies around. And we'll go ahead and define the enemy prefab. I already have, or sorry, the projectile prefab using the enemy projectile prefab that I provided. And we'll say the fire point is that muzzle that we created a second ago. Just put that over here. And again, that's where the projectiles are going to instantiate. I'll go ahead and add a player for now, just so that we can have it there. So we'll say 3D object, we'll make it a capsule. And we'll just call this player target. All right, it's not going to be a player. We're just putting it there for the sake of having something to shoot at. And we'll make sure that this has a rigid body because we need one of those for the drone agent to do predictive aiming. We'll set this so that the gravity is false because I don't want it to be falling every time I move it. And I'm just going to throw it out for now, like somewhere super high up, so that we can first see the agent patrol, then we can see it run after it. Oh, and I'm going to set its layer to player. The reason I'm going to do that is because in the quadcopter, we have the vision blockers. These are the things that the agent will, like, these are things that block the agent's ray casting when it's trying to find the player. So if we set it to nothing, it'll see through walls. But if we set it to default, it won't be able to see through the objects that are on the default layer. But the player, we set it to the player layer, so it'll still be able to see it. So we'll grab the player and we'll drop it into the player target. And we will also drop it into the player target rigid body like that. And now let's go ahead and save. So one more thing, I do want to change the radius to something like 0.5. It is a little bit small, and for some reason, Unity seems to be giving me issues when the radius is for the sphere collider is a lot smaller than this. I'm not entirely sure why, but if your radius is around 0.5, should be good enough. So I just want to make sure that the quadcopter is outside, the muzzle is outside of that 0.5 radius. I think that's good. And then I do want to make sure that our connectivity is, 0.5. So we'll just bake that just to be sure. And now let's go ahead and give this a try. And I don't have my camera set up, but we can look at the drone in our scene, and there you go. It's flying around. Okay, so it's navigating. And you can see it'll tell you if it has issues finding a way to the next waypoint. There you go. Cool. Now, sometimes when you have issues like this where it'll fail, it's usually because it has to sample a certain amount of cells in order to get to where it needs to go, right? I hard-coded the value, I believe, inside of the agent to something like 50,000 tries. There's two ways to approach it. You can either expose that value to your agent and be able to change it on the fly, or you can update your navigation volume so that it has less cells that it needs to evaluate. And the way you can do that is by changing the volume size, the voxel size. We'll bake. It'll take a second. And you just need to make sure that you rebake your connectivity. So it's baked. And now you can go ahead and run this. And it should be able to find those waypoints. Now, because we did change our agent radius to 0.5, I would suggest going into your patrol points and updating your waypoint visualizer to 0.5. That way it's more realistic, and now you can see that it can reach things. And like I said, the reason that happens is usually because of how many samples you took. And to illustrate that point a little bit further, I added some debuggers to help with with debugging specific scenarios like that. So I'm just going to create a few empty game objects, and we'll call these Pathfinding testers, and we'll add the component of the same name. And what this does is this kind of debugs the exact same thing the Pathfinder is doing, but you can do it in your editor so you can kind of preview things in advance. So if you grab a patrol point and you drag it into your start, and then patrol point 1, drag it into your end, and then you grab your connectivity. I think I dragged the wrong thing. Let's try that again. Connectivity, like that. So you'll see that there's the max nodes to evaluate, right? So I'm just going to need to auto update so that I can see it as it moves around. So if I were to come here, the default is 50,000. I think I said it was 5 million. That's not correct. If I were to simplify this down a little bit, you'll see that it says pathfinding failed. It is reachable, but it's not able to find a path because of because it's not checking enough nodes. So if we increase this to 500, I think it should be able to find it. Nope, even 500 is too low because it's trying to find a path and it's only evaluating 500 nodes around it. There's a lot of nodes in here, right? I think there's like 4 million nodes or 2 million nodes or something. So there's a lot of nodes for it to evaluate. And you just need to make sure this number is high enough. 50,000 seems to be the sweet spot in this case. If you needed to be a little higher, you can go a little higher, right? And again, this is relative to the volume size. I might introduce some improvements in the future that automatically updates this value for you. I decided not to do that because I didn't want I couldn't foresee all the performance issues that could come as a result of that. So I decided to keep it manual for now. But yeah, so we'll see if the need arises, then we'll probably increase it. But if not, then this should be fine. And you can see like now we can find a path. So it's a good way to like test between paths whether or not things are reachable. And again, this is a huge. It might not seem like it, but it is a humongous area. Usually, you wouldn't be using this many cells, this much volume with these many cells in a level like this. But if you do, then this is a caveat to be aware of. So that was a good little segue into showing the pathfinding tester, another little debug tool for you to use. Try to not have this in your scene because it can be a performance drain since it's always updating. If you set it to auto update, it's kind of unnecessary to keep there. So that's kind of our basic example. Oh, but I didn't show you how the combat drone does its behavior updating. So let's just hit play again and let it do its thing. And now I'm going to grab the player and I'm going to drag it down a bit and I'm going to put it in the front of the, oh, there you go. So you can see the drone has found it and it is attacking it, right? So this is not necessarily part of the package. This is just, well, it is part of the package, but this is specific to the sample. So if you want to see how this is done, you can look at the code and analyze it and deal with it and stuff. So I'm going to move the agent outside of the volume and it's going to be searching. It's not going to find it. It's going to perform some random checks, random points that it finds that it searches, doesn't find anything, and it goes back to its patrol. Pretty simple, pretty straightforward. Okay, we can go ahead and stop this scene. So now let's go ahead and we can head into a little bit more of a complex example that I'm going to speed through because it's going to be a more or less of what you've just seen. Let's head into our Polygon City pack. So this is if you have Polygon Sci-Fi City, excuse me, feel free to follow along. Otherwise, go ahead and head into the demo scene. And I am just going to duplicate this scene. Whoops. And hit Control D. We'll call this demo combat agent. We'll call it Cinti Sci-Fi City combat agent. Okay. I'm just going to drag and drop this into my scenes folder like that. And then, brother, what the heck? Oh, okay. Okay. I'm not going to save that. And I'm just going to do some cleanup real quick. There are some extra stuff in here that I don't want to consider, like this right here, the small vehicle, future cop. So I'm just going to do small vehicle, and I'm going to select all of these. Hello. I'm going to select all of these and delete them. There's also a bunch of drones in here already that, like, these are not really good props to have because they're gonna fudge with the navigation volume baking, and they're static representing dynamic objects, so it doesn't even make any sense to keep them anyways. I'm gonna go ahead and add a volume like so. We'll go ahead and resize it. We'll say 120 by 120 and give it a size of, like, I don't know, 50 or something. Kind of what we did before. But let's move this somewhere closer to the center. I think it's like a -20, 0, 20. That should be fine. Yeah, it's good enough. Make the obstacles default. Give this a voxel size of 1. Go ahead and bake. Okay. Now, there's an issue with the Cinti asset where, like, some buildings, they just don't have colliders, which is, like, really frustrating. But the easy way to handle that is, like, you can select these and search for all of them and then just, like, literally manually add the mesh like that. And you can make them not convex so that way they're not taking up the entire space. Okay. And yeah, so now that we added those, the thing that you're going to want to have to do is the volume has no knowledge that you just made things change, right? You would never get anything done with how many calculations it would have to do if I made it automatic. So for that, we just go ahead and bake again so we can update it to account for those towers. So you'll see this one should start. Yep, there you go. Now it's showing unnavigable voxels. I am not going to do that for everything right now because there's way too many things in here, and a Cinti should fix their asset. But if they don't, then, you know, just be aware of this when you're using this for your own games. Okay, so now let's go ahead and add a drone. So I'm just gonna come up here and look up one of the Cinti drones. So we'll grab that bad boy right there and hit F to zoom in. Let's move them up a little bit so I can see them. Cool. I'm going to remove the mesh collider on it because I don't like it. Remove. And I'm going to add a sphere collider. We'll make this 1.5 just so that it's nice and all-encompassing. And then we'll add a combat agent. I do need to add a connectivity analysis graph. So come down here, we'll hit nav3D, connectivity analysis. And wrong thing. Let's grab the volume, put it in there. We said the agent was 1.5. Bake that, go back to the agent, define the connectivity like so. Let's add a few patrol points. So we'll call this patrol point. I'm just going to do 2 like so. I'm going to add visualizers for these. So again, that was waypoint, excuse me. We'll grab the volume like so, and we'll set its radius 1.5 like the drone, and we'll zoom out a little bit and move them around real quick. So we'll put the first patrol point where the drone is. The second patrol point, we'll move this like somewhere over yonder, like that. And then the third patrol point, we'll put it somewhere like that, right? We'll lower it a little bit so we have some more like interesting navigation. Yeah. So now let's go back to our drone. I'm going to lock this and I'm going to select these 3, drop them into the patrol points. This drone does not have a rotor. It does not have any rotors or propellers, so we don't need to set these. We can add a player like so. We'll do this. We'll make this one a sphere this time, and we'll just say player. And for the player, we'll put it on the player layer. Player layer. Say that fast 5 times. Give it a rigid body that does not have gravity defined. We'll move this somewhere over there, right? And then we'll go back to the drone. We'll drag the player into the target and into the player target rigid body. We need to add a projectile, so we'll just use the built-in one, enemy projectile. And we need to add a fire point. So let's add a child object to this thing. We'll call it muzzle. Okay. Zoom in real quick on this, and we'll just place this. Remember to keep it outside of the collider, so that should be fine. Let's click on this to make sure. Yep, it's outside of the collider. So now we can grab that muzzle like so, and we can go ahead and, yeah, just save this and hit play and see. Oh, wait. Don't do that yet. Change this to the specific layer we talked about. So we'll change it to drone. Yes, change children. And I am going to change the vision blockers to default. Save it again, and then we can hit play. Oh, wait, you know what? Here, let me modify our camera. So for our camera, we're going to add the follow camera, which comes built in. Follow camera. This comes built into the package. We will add our drone to this. We'll set the smooth speed to something like 2, and that should be fine. Save that, then hit play. Okay, and there you go. We can turn on the gizmos if we want to debug it. And you can see it navigating around in 3D. Looks pretty cool. It's going to spot the player in a second. Somewhere over here. There you go. There's the player. Now it's investigating. It's firing at the player. And then we can go to our scene, view, grab the player, hit F to... oh, I didn't realize it would react to the... Oops. Man, I can't move it. But let me disable the... That's crazy. Yeah, because it's got a collider on it, so it's so funny. So we can move this around and stuff, and it'll keep searching for it. But we'll go ahead and we'll just like put this... Let me turn off the collider because it's kind of going crazy. And we will... Hello. Okay. Let's just go ahead and disable this. Oh, didn't work. Move it out of the existence. Just send that thing into the void. Wrong place. Let's go back to the drone, and the drone lost it, and now it's going back to the route. So yeah, there you go. That's Nav 3D. A little bit of a janky demo, but hopefully it demonstrates what it is that you can do with it and how you can use it and how you can use some of the stuff that's built in with it. Yeah, so thanks so much for watching. It should be on the store soon, hopefully. It's currently in the review process. But yeah, if you see this at a later date, hopefully it'll be available for you, and I'll add it to the description. You can get the Cinti asset from the description as well. And yeah, thanks so much for watching, and hope you learned something.